Hi students, now continuation of a chain of responsibility consequences. Coming to the chain of responsibility consequences, in the sense it describes the result of whatever we are applying of this particular pattern. The chain of responsibilities has the following benefits and liabilities. First one, coming to the reduced coupling. What we are reducing, the name says reducing, in the sense decreasing the coupling. Reduced coupling, in the sense the pattern frees an object from knowing which other objects handles a request. Simply, an object only has to know that a request will be handled and it should be appropriate or not, it is suitable or not. Both the receiver side and the sender side have no explicit knowledge of each other, and an object in the chain does not have to know about what the chain's structure. As a result, we say that the chain of responsibility can simplify the object interconnections, and instead of these objects we are maintaining references to all candidate receivers, and they keep a single reference to their successor. Okay, it is nothing but the first reduced coupling. And coming to the second consequences, added flexibility in assigning responsibilities to objects. Yes, we are adding added flexibility in assigning responsibilities to objects. In the sense, what does the meaning? In the sense, chain of responsibility, it gives you added flexibility. It should be flexible in distributing some those responsibilities among those objects. You can add or change responsibilities for handling a request by adding to, or otherwise we are changing the chain at runtime. Especially you can combine this situation with subclassing to specialize handlers statically. In the sense, you can combine this with subclassing to specialize handlers statically. And coming to the third consequences of a chain of responsibility, it is one of the best benefit and liability. Recipient is not guaranteed. Yes, exactly, recipient is not guaranteed, since during a request has no explicit receiver and there's no guarantee it will be handled. So the request can fall off the end of the chain of responsibility without ever being handled. So a request can also go unhandled when the chain is not configured properly. This is the third consequences. Recipient is not guaranteed. And coming to the implementation section, we are studying four concepts in implementation section. Here are implementation issues to consider in chain of responsibilities. The first one is nothing but implementing the successor chain. There are two possible ways we need to implement the successor chain. First one, we need to define new links, usually in the handler, and but concrete handlers could define them instead of. And coming to the next thing, use existing links. In the sense, our example, so far we define new links, but often you can use existing object references to form the successor chain. For example, parent reference in a part-whole hierarchy, it can define a part successor. So a widget structure might already have such links. So composite design pattern discusses present parent references in more detail. We are using existing links work well when the link support the chain. You need it to save you from defining links explicitly, and it saves space. But if the structure it does not reflect the chain of responsibility, whatever your application requires, then you have to be defined redundant links. And coming to the second key point here, connecting successors. What we are connecting successors, in the sense, if there are no pre-existing references for defining a chain, then you will have to introduce them yourself. In that case, the handler not only defines the interface for that particular request, but usually you need to suppose to maintain the successor as well. So that's the handler provide a default implementation of a handle request that forwards the request to the successor if any. So if a concrete handler subclass is not interested in the request, so it does not have to override the forwarding operation, since its default implementation forwards unconditionally. And coming to the third concept, that is nothing but representing request. How we represent that particular request, in the sense different we are studying here different options are available for representing request. In the simplest form, the request is a hard coded operation invocation. As in this case of handle help, this is convenient and safe, but you can forward only the fixed set of requests that the handler class defines. An alternative is to use a single handler function that takes a request code, for example an integer constant or a string, as a parameter. This supports an open-ended set of requests. So the only requirement here is that the sender and the receiver agree on how the request should be encoded. Okay, so this approach is more flexible, but it requires conditional statements for dispatching the request based on its code. Moreover, there is no type safe way to pass that parameters, so they must be packed and unpacked manually. Obviously, this is less safe than invoking an operation directly. So we need to address the parameter passing problem. We can use a separate request object that bundle request parameters. Request class can represent request explicitly, and new kinds of request can be defined by subclassing. So the subclasses can define different parameters. So your handlers must know the kind of request, that is which request subclass they are using. We are supposed to access these parameters. Just we need to identify the request. It can define an accessor function that returns an identifier for the class. Alternatively, the receiver can use runtime type information if the implementation language that supports it. Okay, and coming to the fourth implementation, automatic forwarding in Smalltalk. In Smalltalk, we are studying automatic forwarding the request. You can use does not understand that process in Smalltalk to forward request. So here messages that have no corresponding methods or trapped in the implementation of does not understand, so which can be overridden to forward the message to an object's successor, so that it is not very necessary to implement forwarding manually. So the class handles only the request in which it is very interested, and it should based on rely on does not understand whatever we need to forward to all others. Okay, to all others implement forwarding manually. Okay, and coming to the noun uses. Noun uses in the sense, what are the suitable examples of the real world of this pattern related to that. Several class libraries uses the chain of responsibility pattern to handle user events. So they use different names for the handler classes, but the idea is the same. Whenever the user click the mouse or presses a key, an event, an action get generated and passed along that chain. For example, here Mac app and ET++ call it event handler. Semantics TCL library call it bureaucrat. Next, NEXT's AppKit uses the name responder. Likewise, UniDraw framework for graphical editors. For graphical editors, we are drawing the graphical editors, UniDraw framework for graphical editors. Here the UniDraw framework for graphical editors defines just command objects that encapsulate request to component and component view objects. So the component and component view may be structured hierarchically. So a component or a component view may forward those command interpretation to its parent class, which may in turn we need to forward to its parent, and so on. Thereby we are forming a chain of responsibility. In the sense, a component or a component view may forward command interpretation to its parent class, which may in turn forward to its parents, and so on. Thereby we are forming a chain of responsibility. And coming to the section of ET++, here we uses chain of responsibility to handle graphical update. So a graphical object calls the invalidate rect operation whenever it must update a part of its appearance. A graphical object can't handle invalidate rect by itself because it does not know about its context. Okay. And coming to the related patterns of chain of responsibility, the chain of responsibility is often applied in conjunction with composite. If you know composite design pattern, to compose tree structure representation as a part whole hierarchy. In the sense, we are representing the tree structure as a hierarchical manner. Okay, there's a component a parent components there. A component's parent can act as its successor. Okay, here the related pattern of chain of responsibility, that is composite. Chain of responsibility is oftenly applied in conjunction with composite. There a component's parent can act as its successor. This is the concept of chain of responsibility design pattern. If you have any doubts regarding the concept of chain of responsibility, can you please contact me. Up to now, thank you one and all, ma.